Alright, we're going to finish up Unit 2 here with Lesson 7. We've got two objectives. Graph a linear inequality in two variables and solve a system of linear inequalities. Okay, all the inequalities we've been looking at so far have been single variable inequalities, so that when we graph them on a number line. But now we're looking at graphing on a coordinate plane. First of all, there's a little rule that we need to talk about. Has to do with what the actual line looks like. If you have an inequality that has a less than or a greater than symbol, then you have a dotted line. This means your line is a dotted line, or dashed if you prefer. I'll probably draw it dashed. It's kind of hard to make that many dots. But if your symbols are less than or equal to or greater than or equal to, then you have a solid line just like you would regularly draw on any equation that you were graphing. So let's look at an example. Let's say I wanted you to graph x plus y is less than 7. Okay, this is a line, but we're looking for all points that satisfy this inequality. X plus y is less than 7. Well, we're going to start by graphing the line x plus y equals 7. Now, since this symbol does not have an or equal to underneath it, right? Since it's just a less than symbol, we know that our line itself is going to be dashed or dotted. So probably the easiest way to graph this is just to pick a couple of points. The intercepts are pretty easy to find. If you do this good old-fashioned number here, right, where you take x and y and you set x equal to 0 and you set y equal to 0, that'll give you two different points, right? Remember, we're graphing, this is for the line x plus y equals 7. We're trying to graph the line first, and then we'll deal with the inequality. So if I plug in x equals 0, well then that's 0 plus y equals 7. So obviously y has to be 7. And likewise, if I plug in 0 for y, well then that's x plus 0 equals 7. So in that case, x has to be 7. Well, that's enough to graph my line because I have 2 points. So I've got 1 point at 0, 7. Let me do this in black will work. Make sure I get it on the right spot. So there's 0, 7 right there. And then I've got another point at 7, 0. Let's see if I can pull this off. I haven't used this tool yet, but we're going to attempt to draw a straight line through these 2 points. Well, that's straight-ish. There we go. That'll work. Let's put arrows on the ends. Nope, not going to do it. Okay, doesn't matter. Good enough. Pretend there's arrows on the ends. Well, I'll draw arrows on the ends. How about that? Apparently it's going to be red. I didn't know it was going to be red, but it's going to be red. Okay, so we've got there's our straight line. You have to use your imagination a little bit because it's supposed to be going directly through 7, 0. But there's our line. Okay, and what I shouldn't have done is what I just did, which is to erase it. No, that's not what I meant to do either. Tell you what, let's just draw this without that, because what I did is I drew it solid, and that's a mistake because it needs to be dashed. Let's just try this all over again. I'll draw it red, that's fine. Here we go. This time making the correct line, hopefully. Okay, and remember, it has to be a dashed line because it was x plus y is less than 7, not less than or equal to. Okay, so that's the line, but now all we've graphed is x plus y equals 7. We need to know which side of the line satisfies our inequality. The easiest way to do this is pick a test point. Pick a point on either side of the line. Whenever I can, whenever the line does not go through 0, 0, I always choose 0, 0 because it's going to be the easiest point to plug in and test. So let me take that point right there, 0, 0, and I'm going to plug it in. Well, if I plug in 0 for x and 0 for y, is it true that that is less than 7? Yes, it is true. That makes it true. 0 is less than 7 because 0 plus 0 is 0, right? So what does this tell me? Well, that tells me that every point on this side of the line is a solution. So if I were shading this, I would shade all of this in, because everything, and this line goes on forever and ever, of course, I'm just stopping right there. Everything on this side of the line is a solution to that inequality. So we know that every point below this line that I've shaded in, if I picked that x and y value of that point and plugged it into the inequality, it would make it true. And the reverse is also true. If I just select some point at random up here, like if I pick this point up here, so I meant to do that with a pen, not with a highlighter. If I pick that point right there and plug that x and y value in to this inequality, it will not be true. I will get a number that is greater than 7. So that is how we graph inequalities. Let's look at one more. Let me see if I can copy this real quick. Paste it. All right, let's look at another one, because we don't want to just give you one example and run. Let's graph. Well, let's have my phone ring first, and let me pause this. All right, I apologize. Where was I? I was about to give you an inequality graph. 2x minus y is greater than or equal to 3. Oh, hello. Sometimes it's easiest to graph it to get it into slope-intercept form, and that's what I think I'm going to do here. So let's do that. Just as a reminder, slope-intercept form is y equals mx plus b. So in other words, I'm going to move everything over to the right side except for the y. Okay, so let's start by subtracting 2x. Right? Let me rewrite the problem underneath here, because I want to get it in that format. So I'm going to subtract 2x from both sides. When I do that, I'm going to have negative y is greater than or equal to negative 2x plus 3. I canceled this 2x out. Right? Now, be careful here. I have to divide by a negative 1. I have to divide everything by a negative 1 to get rid of that negative y. Now, remember, when you divide an inequality by a negative, that flips the direction of the inequality symbol. So now I have y is less than or equal to positive 2x minus 3. Notice I changed all of my signs. Okay, so this right here is the inequality I am looking to graph. I scooted down a little bit too far. I went past the graph. Let me see if I can grab the graph and bring it down a little bit. No, apparently I can't. Sure I can. There we go. All right. So now I am going to graph y is less than or equal to 2x minus 3. Let's remind ourselves what that means. Remember, this b, this number that's out here all by itself, that's my y-intercept. So this is telling me it crosses the y-axis at negative 3 and has a slope of, remember, this number in front of x is my slope, and any whole number I can always put over 1. So that means I go up to right 1 from my y-intercept and I get another point. You can do that as many times as you want. Up to right 1, up to right 1. I can do that over and over again. Or you can go down to left 1. You can go the opposite direction. Anyway, that is my line. Now, is this line solid or dashed? This is a solid line because it's less than or equal to. So I'm going to draw a solid line through all of these points. And now we just have to figure out which side of that line to shade. Again, I'm going to use 0, 0 as a test point. I think it's the easiest point to try out whenever possible. I always use 0, 0 because those are easy numbers to plug in. Okay, I really do have to scroll down now and give myself some more space. So if I replace y with 0 and x with 0, I have 0 is less than or equal to 2 times 0 minus 3, which comes out to 0 is less than or equal to negative 3. Okay, I had to pause again, so now I have to completely regroup and figure out what I was saying. We just plugged in 0, 0 as a test point, and now I see that when I plug in 0 for y and 0 for x, I come up with this equation here, right? No, I erase things. That's what I do. I erase things. Perfect. I love it when that happens. I really do. It makes me so happy. I come up with this. I said any equation, but I meant inequality. I'm a little anal. It bothers me when there's any white space in there. So I've got 0 is less than or equal to -3. That is not a true statement. 0 is not less than any negative number. Every negative number is smaller than 0. So this, do it in blue since I wrote in red, because it gets a big old X. That is not true. Well, what that tells me is the side of the line with 0, 0 on it is not a solution, so I need to shade the other side. So I'm going to shade in here. And when you're doing this in my math lab, what you'll do is after you graph your line, there's a little icon that's like a little paint bucket. It looks kind of like this. It's got like this, and there's like paint spilling out of it, or something like that. I think that's kind of what it looks like. You'll click on that icon, and then you'll just click. You'll either click on down here on this side of the line, or if you click up here on the left of the line, then it'll shade all of that in for you. So you won't have to physically shade anything in. You'll just have to choose which side you want shaded. Okay? So that's pretty much how you graph a single linear inequality. Now let's look at some really basic systems, because I don't want to get too complex here. I gotta paste again. And let's bring this over a little bit. And let's look at this system. You've got the system y is greater than -2, x is less than or equal to 5. That's your system that I want you to solve graphically. Okay, now this is a really basic one, pretty straightforward, because these two lines are really easy to graph. Chosen that way on purpose. So let's come over here and graph it and see what we have. Y is greater than -2. Hopefully by now you recognize that that is a horizontal line. If not, you'll see it in a second. Because remember, -2, well, that's right here. Y equals -2. Well, if y, there's no x value. It's just y. Remember, I'm graphing y equals -2. And on this one, I'm going to graph x equals 5. For y equals -2, what it's saying is, give me the line that every point on the line has a y value of -2. Well, that is going to be a horizontal line. It's going to be this horizontal line through y equals -2. Now, notice it's dashed, right, because that's y is greater than, not or equal to. Now, the other line, x equals 5, well, think, if x equals 5, then it goes through this point right here on the x-axis. And this is the line that is the set of all points with an x value of 5. Well, here's a point with an x value of 5. Here's a point with an x value of 5. Here's a point with an x value of 5. So this is just a vertical line. X equals lines are vertical lines. Y equals lines are horizontal. And notice this one, even though it's not quite straight, I made it a little wavy, that one is a solid line because its x is less than or equal to. Now, you don't really have to pick a test point here because these lines, it's pretty easy to tell. But try 0, 0 again. If you choose 0, 0, 0 for y is 0 greater than -2? Yes, 0 is greater than -2. Is 0 less than or equal to 5? Yes, 0 is less than 5. So that works for both inequalities. Any test point you choose must work for both inequalities, and so I know where I need to shade. Now notice, with a system, we actually have 4 regions, not 2. So the only region being shaded is this one here. This is the region I'm shading in. There's all my set of solutions are going to fall within that region there. Why? Because this is the set of points that have a y value greater than -2, so they're above that line, but their x value is less than 5. So they would all have to fall in this little square here. Alright, let's look at one more and then I'll be done. Okay, well, apparently I'm going to do that first. Alright, let's look at a system that has y and x in both. Let's say y is less than or equal to, no, let's not do that. Let me do something a little different. Not 2. Well, okay, come on, you can do it. Alright. 1/3 x plus 1, and then y is less than or equal to 5x minus 5. There's my two lines. Okay. 1/3 x plus 1. I've already written both of these in y equals mx plus b format. They also both have an or equals to on the inequality symbol, so I know that they're going to be solid lines. So let's just go ahead and graph them. 1/3 x plus 1, well, it crosses the y-axis at positive 1, and it has a slope of 1/3. So I go up 1, right 3, and I make another point. I can do that again, up 1 and right 3, up 1, right 3. Or I could go down 1, left 3. Down 1, left 3. I could do that until the cows come home. Or until I run out of grids on my coordinate grid here. So I'll just go with that. There's my line. Pretty straight line, if I do say so myself. And now let me graph the other line. Y is less than or equal to 5x minus 5. I go down to negative 5 and make a point, because that's where it crosses the y-axis. Remember, a slope of 5 means 5 over 1. So I go up 5, right 1. I go up 5 again, right 1 again. I could, again, do this multiple times if I so desire. I can also go down 5 and left 1. And there is that line. This one will probably be crooked since, oh yeah, I knew that would happen. Since I bragged about my straight line on the last one, I knew that one was destined to be crooked. Whatever, it's just going to have to do. Can't draw straight lines up and down apparently. So there's my two lines. Now we need to figure out where is the solution. What points are less than or equal to both of those lines. You could try 0, 0, but what you'll find is that is not a solution. And let me show you why. So here's 0, 0. If I plug in 0, 0, if I plug it into the top equation, I'm going to get 0 is less than or equal to 1/3 times 0 plus 1. Well, you can see that's going to be true, because basically what I get then is 0 is less than or equal to 1. That's a true statement. Yep, that works. But if I plug it into the bottom one, 0 is less than or equal to 5 times 0 minus 5. Well, that gives me the statement 0 is less than or equal to negative 5, and that is not true. So what we know is this. 0 would have been a solution for this line. 0, 0 was a solution for this line, but it was not a solution for the 5x minus 5 line. Well, that tells me that the solution must be over here then, because it still has to be below the other line. And you can check that and see. We'll just pick a point in this region. Let me get rid of all of my... well, there we go. Let me shade it in first, and then I'll go back and pick a point. So this is the region that is the solution. Now, just to prove that it is, let's pick some random point in here. Let's choose an easy one. So let's see, I'll go with this point right here on the x-axis. That point is 3, 0. So if I use 3, 0 as a test point, let me get rid of my red here so that, whoa, apparently I'm going to move this around and squeak. Oh, give myself the goosebumps there. Added benefit of this course is you get to listen to me talk to myself. I know that's what you were hoping. Okay, so 3, 0. Remember, that means x is 3, y is 0. So let's try plugging it in. Let me do this in a different color so it shows up a little bit. Let me plug it in to the top equation. That gives me 0 is less than or equal to 1/3 times 3 plus 1. Let me go up. I'm actually going to work backwards here. Go from bottom to top. 0 is less than or equal to, think 1/3 times 3. Well, that's 3 over 1. 1/3 times 3 is just 1. So what this gives me is 0 is less than or equal to 2. 1 plus 1 is 2. Yes, that is a true statement. Let's look at the bottom one. 0 is less than or equal to 5 times 3 minus 5. So 0 is less than or equal to 5 times 3 is 15, minus 5 is 10. Yes, that is a true statement also. So that point works for the top equation and the bottom equation, or I'm sorry, the top inequality and the bottom inequality. So we have shown that we've highlighted the correct region. All right, you should be good to go. You only have a few of these systems on your assignment. It's mostly just the single linear inequalities. Good luck, and as always, contact me if you get stuck on anything.